Okay, so welcome to what I hope will be the first of many videos on a new subject that I'm going to approach. Now, I apologise, this may be a long intro. I will put the description in the description down below, the time for the start point of the actual content of the video. But I just need to do this introduction just so you know what it's all about, and hopefully there'll be something in it for you too. So what the aim of this set of videos is, I like to not just make things, but I like to personalize. So for example, there may be a part work out there, a few part works, and this part work may perhaps do something or not do something that I want it to do. For example, a friend of mine recently did a video. It wasn't a part work, it was a Lego style build, and he wanted some headlights on it. It didn't come with headlights, so he rigged it up and put some LEDs in it, and voila, he had what he wanted. Now I've just started getting into 3D printing, and there's things that I'd like to make and do, and I feel the one thing that's going to tie this all together is electronics. Now, the only problem with electronics is that I know nothing about them. All I know is that anything that you have that's an electronic device, be it a calculator or a mobile phone or a computer, they all have the same thing in common, which is that they essentially consist of two parts. One is the hardware, which is the physical hard components. So here we've got some buttons and we've got a display, and then the second component is the software, and the software consists of a computer program, involves lines of code, which is somebody has told this what to do. So when we press that button, there's a command that goes through. So with the combination of buying electronic components and a little bit of programming, hopefully I'll be able to make lots of interesting things. So what this video is, it's my journey from knowing nothing to hopefully building something completely unimaginable. How far that will go, I don't know. So therefore, I'm not going to call this instructional videos. I'm not even going to call it a diary. Maybe it is a diary, but I'm effectively, this is just going to be a series of videos about my journey. I've bought some electronic learning kits, and they all come with lessons. And what I hope to do is approach one lesson a week. Lesson one will be on this video, and obviously, like most good educational systems, lesson one will be so simple you may even find it boring, but as the lessons progress we will learn more and more, and obviously you'll start to realize that lesson one is very important. So for example, if you're learning to write, it's very important to know what a pen is, because without knowing what a pen is you can't write. And we as adults, we've been doing this for so long, we forget the absolute basics because it just becomes second nature, and the same is true with electronics. So this is a wire, we need to know why wire is important. So bear with me on the first few videos. We're going to be going through things very slowly, although I'll give you a bit of an inside information. I've actually, as I'm recording this, I've actually done a few lessons so that I can prepare a few videos in advance, and I can tell you that by the time we get to lesson 3 or even 2 to a certain extent, things do get exciting very quickly. So hopefully you're still here, hopefully you'll watch this video. We'll go through the things that I've bought. I'll go through the prices that I've paid, because not all of you are from the UK. I will quote the prices obviously, but then I will describe the prices in terms of minimum wage. So for example, if something costs X amount of pounds, and then I don't know, let's say something costs £30, and the minimum wage is £5 an hour, which it isn't. Then I would say that's 6 hours work. So it gives you an idea of, you can then hopefully relate that. So if you're on £10 an hour, um, then obviously that becomes three hours wages. But yeah, okay, I'm off topic now. So hopefully you'll enjoy the video. We'll go through the components that I've got. We'll try and grab an understanding of things. Now each lesson, what it does, the way the lessons are laid out, they may not all be like this, but what we will do is we will describe what we're going to do. We're then going to go through the hardware that we require, and then we go through things that we may need to know, so new things. Then we go through what's called a schematic, which is a picture of how we're going to do things. Then we're going to go through a diagram of a layout for us. Then if there's any coding required, we go through that. We look at any new words that we've got, and then we look at maybe a picture of what it could actually look like, and then hopefully we will see a finished result. So hopefully guys you'll enjoy this. Okay, see you later.
Oh no.
Mind the gap.
Okay, so like most things, before you want to start a project, obviously you need to buy things. Now the items that I've purchased is probably overkill, far more than I actually needed, but at the same time there's going to be other things that I need that I haven't bought. So the first thing that I bought is this Electronics All-in-One for Dummies. Now this is an 8-in-1 book. I've had experience with these dummy books before, and I found them very good. They take things to a very basic level, and the way that the book is laid out is very good. However, I cannot give you a rating on this book or any kind of review, because at nearly 900 pages, as you can imagine, I've not even scratched the surface with this. But the aim of this is that when I'm away from the computer, or not able, maybe just late at night, I can read a few pages, and over time this book will get read. Now the next thing that I bought is, I'm going to call this an Arduino board. Now Arduino is a copyright-free processor, and this is the starter kit. Because it's copyright free, anybody can copy it, and in fact at some point in the future I will actually be able to make an Arduino board. There's lots of different ones that they do, but this is one that's perfectly adequate for starters, and it will take you way beyond starter. So I won't go through all of the components that you get, because these will come up as we progress through the lesson. So obviously if there's a component that we've not seen before, I will say, oh, next we need such and such, which comes out of the starter kit, etc, etc. So this is £15, £14.99. Now that equates to approximately 2 hours wages at national minimum wage, and there is a host of lessons here that will be able to give us a good start in electronics. As you see, it comes in a nice little box. We get this little board. Now this board, it's effectively, at the most basic level, it's a power supply. You may have played with electronics as kids, and you'll get like a little 9-volt battery, and you'll hook that up to something, and then that's the power supply. It also comes with a breadboard, which I will go into breadboards as we progress with the lessons. But essentially, a breadboard is a circuit board, but it's not permanent. So you don't need to solder things. You just need to plug them in and away they go, and it enables you to practice something before you actually solder it um, permanently. Now, I am a long way from doing circuit boards. I'm still at the learning the electronic stages, so I won't be soldering anything. I won't be making circuit boards for quite a while. However, this breadboard will still enable us to learn and demonstrate exactly what we intend to do. So there you go. So the next thing that I bought, which is probably way overkill, this is pretty much the same thing as a starter kit, but this one's called the most complete ultimate starter kit. It contains the same things as the starter set, plus much more. So, for example, you can see there we've got a power supply. So now we can draw power directly from the sockets. We've got you can see there we've got a remote control to play with. We've got a keypad. Some of these components, like these LEDs and these wires, they're contained in the basic set. And we see we have another, it's called an Uno R3, but that's basically the processor, and that comes with it. But you can see how cheap these are. They're really not expensive. And you compare them to, say, a computer. Computers are obviously a lot more expensive. By computer, I mean a laptop or a PC. But in all fairness, when you stop and think about it, the reason a computer or a laptop is far more expensive is because you not only have the basic processor, but you have various controllers and boards, graphics cards, sound cards, CD drives. They're all the things that drive up the cost. We actually don't have enough components here to make a PC, because obviously we need things like say the CD drives and stuff, and but we have things that we can do add-ons, and as our knowledge grows, who knows, we may actually be able to build a PC from scratch. And the last thing that I bought, again, which is probably overkill, these are little modules that you can get. These start at a more advanced level. So you have here, again, I won't go through all of them. Half of them I don't even understand at this stage. But we've got a joystick there. So that would give us the ability to control things. We've got I'm actually looking for things that I can understand at the moment. So there we go. We've got a digital temperature. So perhaps we can use that that module to make a thermometer. Temperature, humidity, infrared receiver, infrared emission. Now, my understanding of that is that's perhaps the way that TV remote controls work. I may have a lot of this wrong, but this is my learning journey. So, and again, you see it comes in a nice little box. Now, all three of these, the two starter kits and the module kits, they come with a CD, as you can see, and they all contain lessons. So this particular box, sorry, I just want to go back to the complete starter kit. I forgot to tell you the price. Now, the price, I don't know how long that price is going to hold for. When Amazon says price scribbled out and then sale, it doesn't necessarily mean it's going to be that price all the time. But I did buy this for £44, which, where I come from, that's approximately just under 6 hours work at national minimum wage. So it gives you an idea of the cost. But obviously a full price is £52, and this 37 in 1 sensor pack is a little tiny bit more expensive than the book. So yeah, there you go, guys. That is what I've bought. So next we'll actually go into the components, and we'll start to look at it in more detail. Okay, so while I do the unboxing of the starter kits, I'm just going to go through the getting started guide. I won't go into too much detail because a lot of it will be quite everyday things for people. But obviously, people are welcome to leave comments to ask further questions, and I can then deal with that in a future video. So the CD comes with a 15-page PDF document, which I've printed off, a 16-page, sorry, and obviously you don't have to print it off, but I find it a little bit easier and it's there for me. First of all, it goes on about the Arduino IDE, which IDE means Integrated Development Environment. Now, Arduino software is easy to use for beginners, yet flexible enough for the advanced users to take advantage of. And that's what appealed to me. I don't like buying starter kits if they don't then take me beyond a starter or beginner. But likewise, I don't go for the advanced things because sometimes you need a certain amount of knowledge before you can even use them. So it would appear to me that this Arduino is simple enough to learn. And to be honest with you, I'm a little bit slow with learning languages like computer languages, and I've actually picked this up very well, as you will find out on lesson 3. Lesson 3 is my first piece of programming, and I actually handled it very well. So I would be confident that any one of you guys would be able to. So it's good for teachers because it's conveniently based on a programming environment. So students learning to program in that environment will be familiar on how the Arduino IDE works. Again, that's not that's not applicable to me because I don't know anything about programming or the hardware. But that says to me it's nice and easy. So the first thing you need to do is download the Arduino software. That's available from www.arduino.cc. That's www.arduino.cc. The link is available in the PDF. And then we download the software, and then while that's downloading, as you can see roughly on the screen just now, we need to get the Uno R3 and a USB cable. Now I didn't find the USB cable long enough, and that's because of my own personal setup. I have the USB cables, USB ports set quite far back from my workstation, and as a result the cable won't reach to the front where I actually work. So I've gone out and bought a new cable, and I've got to be honest with you, in this world of Wi-Fi, I found this cable quite hard to get hold of. If you go back 5 years ago, when printers and things, you needed a USB cable to connect them up to the computer. You could buy them for pennies in just about any applicable store, but because everything's gone Wi-Fi now, it's hard to get hold of. However, I found the cable on Amazon, and it arrived the next day, and it cost me something like about an hour's wage. So step 2 is to install the software on the system. Now I won't go into any detail, but installing the software is exactly the same as any games or anything that you've ever downloaded for your computer. It's all exactly the same as that, just standard installation stuff. So stage 3, connect the board, and all you need to do is just plug the USB cable into the USB port on the board, and away it goes. Looking at the video, I think I've already done that, and it says that once you've plugged it in, basically what it's going to do is it's going to draw the power from the computer. Equally, you can connect a 9-volt battery to the Uno R3, and the connector is supplied with the starter kit. You will also have noticed that I've actually 3D printed a holder for mine. You don't need a holder, and the starter kit actually comes with a little piece of perspex with pre-cut holes and some screws. So you can actually screw the R3 onto a board, and then you can use it from there. But you know, I like to try and be a little bit neater and a little bit flashier. I found something on Thingiverse, I printed it off, and it's working really well for me. So step 4, we need to install the Arduino drivers. Now I think I cheated here because I didn't install all of these drivers, and I just fired it. Well, it just loaded up because step 5 is launch the Arduino software, which obviously I did. But then I found a little option at the top to set things up. Now the PDF does tell you how to set it all up. And in fact I didn't even do all of it, but if you follow the instructions that will be absolutely fine. And I say all I needed to do was select the port, serial port, which is step 8. Step 6 is supposed to be opening an example. Step 7 is to select your board. Now I found mine was already automatically selected. Maybe that's a default setting, I don't know. I needed to select the serial port, which it was actually the first one I attempted. And then step 9 and step 10, which is upload the code to the board, I didn't actually do until lesson 3, and the reason for that is the code that we will be uploading is actually the default code on the board anyway, so I didn't actually do it. We will go through the code, but effectively you're going to be overwriting code with identical code, so it's good for practice. But so, and then it goes on about that the introduction to the hardware, and then it lists all the lessons, and there's going to be, in this starter, the small starter set, there's 21 lessons. It starts with lesson 1, LED blink. So all we'll do is make an LED blink, and then that goes through. Lesson 2 is a trailing effect. Lesson 3 we'll make some traffic lights, and then we go for inputs, fading buttons, passive buzzers, a knob, and then lesson 21 will be temperature and humidity motors, I don't know, it just says because the line length, the description is longer than the line allows, so it just says lesson 21 temperature and humidity mo ... So there'll be a little surprise there. And then the PDF then gives us web links for video tutorials and projects. So there's more resources out there. So in effect, this starter set, it's literally just lightly scraping, and I mean lightly scraping the surface. So let's go into our first project. Okay, so this project is called LED Blink. It's a very simple project. There is programming, which we're not actually going to look at the programming, but we'll just basically the board is already set up to do certain defaults. So here we've got our basic setup. We've got our breadboard, which is our prototype circuit board. We have our Uno R3, which in this particular case is just simply going to be used as a power supply, and then we have our USB cable, which is our actual power supply, that will power the circuit board. We'll call it a circuit board, the Uno R3, and then that will enable us to power the projects. So other than our breadboard, Uno R3 and the USB cable, we need 3 components. We need some jumper wires. Now these will enable us obviously to direct the power to the point that we need them. we need an LED light. We only need one in this instance, and we also need a resistor. Now the reason we need a resistor is because the amount of power that comes through the Uno is far too strong for the LED, so it just needs to be reduced. So what I'm doing here is it's got a nice little specification diagram of the LED light, and then it goes into as it introduces new components that we've not seen before, it then describes them. So it tells us that an LED light is a great indicator light, and they use very little electricity, and they last for ages. Now in actual fact, an LED light, especially in this instance, it doesn't serve us any useful it doesn't actually physically do anything, but it serves as an indicator. Now a useful application for an LED light, I think perhaps the most common one, is as a standby light. So for example, many of us may have a TV. When we switch the TV on, we may perhaps see a green light, and when we switch the TV off, there's a red light. I've got a set of speakers that it has a blue light when I switch them on, and that's the application of an LED light. It's just indicating to us that something is happening. So in the instance of a TV, when the light goes green, even though the screen doesn't pop on within a millisecond, I see that green light, I know the TV is on, and then when I switch the TV off by the remote control, it goes red, so I know it's switched off. Obviously if I cut the power altogether, those LED lights wouldn't come on either. So in this lesson we'll use the most common of all LEDs, a 5mm red LED. You see there I've got a blue light out. This is because at the beginning it says one LED, it doesn't specify, so I grabbed a random LED which just happened to be blue, but once I read it further and it said that we'll be using a 5mm red LED, you'll see that I changed the LED to a red one. This is just so that I'm following along precisely with the lesson. So 5mm refers to the diameter of the LED, and other common sizes are 3mm and 10mm. You'll see at some point that I do measure this. My ruler isn't accurate, but it is accurate enough to tell the difference between 3, 5 and 10mm. You cannot directly connect this LED to a battery, because first of all the LED does actually have a positive and a negative lead. And what that means is that, I'll use a terminology that we use in part works, it's directional, which means that we need the flow of electricity to go in a certain way. If we make the electricity go the opposite way, it won't work. And secondly, if we put too much power through it, it will blow the LED. So we need to limit the power, or a word that they've used in this lesson is we need to choke the amount of current flowing through it. If we don't use a resistor, it may well be destroyed immediately, and of course it could actually do damage to the Uno R3 as it passes way too much current through. And then there are two ways to tell a positive and a negative. Usually you will find that one pin is longer than the other, and it's the one that's longer which is the positive terminal. However, I will demonstrate this somewhere in the video. There is actually a flat spot on the LED. It's a very small flat spot, and it should be found on the negative terminal. Okay, next up we'll need a resistor. Now they have told us that we need a 220 resistor, or 330 ohms, and we need one of those. Now this does come with a nice diagram that tells you how to identify a resistor, and I'll just go through the description. as the name suggests, resistors resist the flow of electricity. The higher the value of the resistor, the more it resists, and the less electrical current will flow through it. We're going to use this to control how much electricity flows through the LED, and therefore how brightly it shines. So in effect, what we're going to do is we have, let's use words rather than numbers. We have lots of electricity coming through the wire that's going to hit that LED and power it, but there's far too much electricity, so we're going to put a little blocker, a choker. We'll use the word choke, and what we're going to do, it's like a little funnel. So we have lots coming in, and we're just going to trickle that down so that it is not so much. If you turned your tap on full, your water tap, faucet, is that what you call it in America? You'll have the water coming out so fast it's going to make a mess everywhere. So the tap is actually acting as a resistor. If you don't turn the tap on so much, the amount of water that comes out is a lot less, and it's a lot easier to deal with, and it won't make a mess. So a unit of resistance is called an ohm, OHM, and this is shortened. There is a symbol which is the Greek letter omega, and basically like I've said, the more ohms it has, the more the resistance. Now the resistors that I'm using today are 4-band resistors. I'm just trying to, sorry, it's a 5-band resistor, and by combining the colours, this tells us what the resistance is. So in this particular case, well, the colour code is, if it's got a black band, it's 0, a brown band is 1, red is 2, orange is 3, and it goes up. Now this is quite a complicated chart, but I can see that the more I refer to this chart, the easier it becomes, because certain colours always mean the same numbers. So obviously as you use electronics more and more, you start to learn the colours. It's a little bit like karate. They wear coloured belts that denotes how good they are at karate. I can't remember what the different colours are. I know black belt is very good and white belt is a beginner, and there's various colours in between. But obviously if I went to karate on a regular basis, I would learn those colours, and I would understand that red might be better than green, or maybe green's better than red. I don't know karate. So as I play with resistors more and more, I will learn that black is a lower value than white, blue is a number 6, and so on and so forth. So this is a 330 resistor. So the colours, the bands should be orange, which means 3, then another orange, which means 3, followed by a black, which means 0. We put those three figures together, 330. Then in addition, there's 2 other bands, and I'm trying to find a resistor as I do the voiceover. So the 4th band is black, so that means it's got a multiplier. Now I will confess I don't understand what the multiplier means. I assume it reduces it even further. Now this 4th band on this one is black, which tells us that it's got a multiplier of 1 ohm. And then the final band is brown in this case, so that tells us the tolerance, and it's plus or minus 1%. So it's, I assume with a low tolerance it means it's quite precise. If it was silver, it'd have a tolerance of 10%, so that could actually, with a 330, that could mean it's anything between about 300 to 360. That's my guess. So this is an orange black. So if, for example, and I'm making numbers up here, if it was black, black and violet, sorry, that's a really bad example because violet means 7, so I've just described 007. Yeah, if it went black, black and blue, that would be 006, so that has a resistance of 6 ohms. So I, having read the instructions and learned, I can see that that's got a very low resistance, so it doesn't actually reduce the current by very much. So like I say, this is a 330. At this point I don't know what that actually means in real terms, but 330 sounds quite a low one to me, because I have seen resistors with an M and then an omega sign, and I know that M means mega, which is a million, and I've also seen some with a K, which means kilo ohm, which is 1,000. So when you're talking about a million, 330 is a rather low number. And the last thing that this is going to describe is the breadboard. Now I found that this breadboard is very, very confusing for about 5 minutes. What you actually have, and you'll need to see the screen unfortunately because it's more visual, on the top and the bottom you'll see a blue and a red line, and then on the side you'll see a plus and a minus. These refer to what we know as the negative and positive terminals. Now if you place a pin or a wire into one of those, it actually makes the whole line powered or accessible. So those that top and bottom two lines, they actually run across. That's quite annoying because I've just brought in the diagram now, but however this does help us with the transistors. So you see that we have a chart there. I have printed it in black and white, and this is the little chart that I've just been looking at, and it helps us identify a transistor. So I'll just remove this and then I'll just start going on about the breadboard again. Okay, so I'll have to do the rest of the description from a still picture because I've not actually got a piece of video for it. So our breadboard, we've got I'm going to call it the power that goes along the top, and then you'll see the next block of dots underneath, and they actually run up and down. So if you popped, for example, a wire from one of the plus terminals which is running across, and then you run a wire from that one to one of the blocks that are running down, the middle blocks, that will then power up the whole line. And then we do that using jumper wires, which are basically wires with a connection on the end that will fit into the breadboard. Once we come to actually making circuit boards, instead of having those connections on the end, we'll just have a normal wire that everybody recognizes, and then we'll actually solder that onto the board. But the breadboard, like I say, it's called a prototype, so it enables us to test it, and then if it works, all good. Okay, the next thing they supply us with is what's called a schematic. Now a schematic is a way that we draw circuit boards onto paper, so that they're recognizable for other people to understand. Now I will be honest with you, at lesson 1 stage I didn't understand this, so I now do understand it, so I will very briefly explain it. I will go more detail in schematics in another video because obviously I don't want this one to go overly long, but essentially what this is telling us is to run a wire from the port 13 on the Uno R3, and you see roughly where my finger is, that's where it's going to go round. Then it needs to go into a resistor, a 220 resistor, which is actually where they've made a mistake on here, because the materials that we needed was a 330 resistor. or possibly, again, this is something that I'm learning. It says 220 stroke 330 ohm resistor, so maybe we could use a 220 or a 330, or maybe it's a range 220 to 330, so we could use 221, 222, all the way up to 330. It doesn't matter. But I went with the 330 resistor, but it says here that 230, and then from that it goes to a triangle, which means well, it says LED, so it's a light, and then a part that you can't see on the on this image. It lastly needs to hook up to a port called GND, Golf November Delta, which means ground, which is the negative terminal. Okay, so next they give us a connection diagram, and this is a drawing of the breadboard and the Uno and the connections. So it's just there to try and help us connect things. Now what I can see from there is that we have a wire coming from the port 13, and that will connect to the upper multiple dots on the breadboard. Then that will go into the negative terminal on the LED. Then the next one down will have the resistor, which will jump over a gap into a next set of power, and then we have a wire going back to the GND. Okay, so next up we have the sample code. Now in this example we're actually going to completely ignore this. We've kept this simple. We don't actually need the sample code in lesson 1. We will use it in future lessons, but for this one we've just skipped over this part. So next they give us an actual photo of their setup, so we can see roughly what we're looking at. Yours doesn't have to be exactly the same as this. However, we did notice that they missed the resistor out. So we won't miss that. I mean, in that example it won't actually work. And then they give us a little table of words that we would have seen perhaps for the first time, or maybe are very important. Now on the PDF document, these are clickable links. These will take you to a website. It's a little bit like a dictionary for electronic terms. Now at this stage there's a couple of words that I recognise. Output means push out something. High and low is on and off. Delay is to make something wait. And two forward diagonal lines is a comment, which is, it's good to put comments into codes, because if other people read it they then understand what you're trying to do. Okay, so this video is going to be played back at about 3/4 speed with a voiceover. I mean, most of my videos are voiceovers, but that will just enable me just to take my time a little bit more. And what I'll try to do is I'm watching the video as I do the voiceover, and I'll try to describe what I'm doing. So what I've done there is I've put a jumper wire into port 13. And that will obviously supply the power. There we go. So I've moved the camera. It's just so that we can get a better view. And as I say, this should be port 13. It's very difficult working with the camera, because obviously when you work, sorry, I apologise, that's the ground, so we're working the opposite way round. But yeah, when you're working on your own, you're just doing the project at home, you just get on with it and you do it and you work at your own pace. Obviously when you're trying to work to a camera, you want everything to be seen by the camera, and it can sometimes get a little bit difficult. So now I'm setting up the second wire, which is going to go into port 13. Now port 13 is pre-programmed to blink. This is why we don't need the source code. But if we reprogram that port 13 at a later stage to do something else, and then we want to go back to this project, then obviously we would have to reprogram that. Now obviously be careful at this point not to let the ends touch, because we have now we have a broken circuit, so nothing's going to happen. But if those two wires should now touch, that will complete the circuit. So it's probably quite important that we plug those wires into the breadboard as soon as possible, if only just to keep them tidy. So the negative, as I'm going to call it in this case, is yellow. It doesn't matter which color wires you use. If you want to use the official colors in your country, in my country, I don't know if they're different from country to country, but in my country live is brown, and neutral is blue. We could always use those, but I'm using what I've got with a starter kit, and there we go. So the next stage is we're going to put the resistor in, and what that's going to do is that's going to reduce the current that's going to go to the sorry, I tell a lie, that's running from the positive lead. I may have to play this back at a later stage to make sure I've got that right, but you've got the power from the positive, then it goes through the resistor. So one before the resistor, that's going to be doing 5 volts of current, and then after the resistor, I'll be honest with you, I don't know how much it's going to do, but it's going to be lower than 5. So there we have an LED, and what we want to do is put the longer terminal, which is the positive, on the same line as the resistor, but then we want the shorter one to go on a different line. Now that's going to be difficult to see because obviously the LED is hiding up the pins, but the longer terminal is actually on the same line as the resistor, and then the second terminal is actually on a different line. And now what we're going to do any minute now is plug that negative terminal into another into the line. And there we go. So that light has now gone on, and as I say, that's blinking because that's what it's programmed to do. We can reprogram that port, which obviously we're not going to at the moment because this is lesson 1. And there you go, we have done 45 minutes just to make an LED blink. However, that I believe has given us a really good introduction into electronics. So we've made a circuit, we've completed the circuit, and we've given ourselves some indication that that circuit has worked correctly. Okay, so I'm going to end the lesson there. Thank you very much for watching. Hopefully the next ones won't go on for so long. Now next week I will be dealing with lesson 2. It should be shorter because I'm not having to go through all of the basics. So what I will do in each lesson, I will obviously address any comments that you want to leave. So if you want to know more details about something that I've featured in this video, leave a comment, and then I'll expand on it more in next week's video. But next week is going to be an LED trailing effects. So obviously we'll go through the lesson plan as we've done on this one. We'll look at the setup. We'll look at we'll look at the sample code, but we won't actually be using any sample code. Any coding, sorry, and then we'll plug it all in. We'll see if it works. We'll see how it goes, and yeah, guys. So that's that one then done. So hopefully you've enjoyed it, and I will see you all next week.